be explaining the changes in the water equilibrium simulation experiment. In part A, the reactants and the products are introduced. Now the reactants will shift so there's something called stress, which the Chandelier's principle states that if reaction is under stress, it will do everything to reduce the stress and find equilibrium, which this is equilibrium, where it's basically a plateau where it consistently stays the same and reverse is equal to forward. In graph B, you'll notice how 5 milliliters of water was added to the reaction, which then was consumed to give the product more, so it even out, so that it eventually make the equilibrium. So that's why it gained but eventually dropped. But this one, the product went up and came down to find the equilibrium with the reaction. So the reverse is equal to the forward, forward is equal to the reverse. For part C, you'll notice how the reactant side was taken out 5 milliliters from the equilibrium for the reaction side. Therefore, it was needed to consume some from the product side, which had this decrease and had the reaction side increase, and eventually, following Le Chatelier's principle, having this stress, it will do whatever it takes to get it back into the equilibrium state, which is here, where they're straightaway in parallel lines for at least 5. You'll notice in D that the stress that is added is 5 milliliters of water to the product side, which means that this will decrease and be consumed to give to the reactant side. Now on a reactant side, it should have gained a little bit more than it did, which can be put in the sources of error, but for our calculations, it relatively stayed the same, but our reaction should have gone up because it was consuming the product side so that it could eventually find equilibrium, which was found here, which also correlates with Le Chatelier's principle, that eventually with any stress, it will do anything to find equilibrium, which is what it did. Lastly, we have E, and if you'll notice, it's kind of hard because I had to do 2 graphs, but it lost 5 milliliters of water, which means that it's going to consume some of the reactants. Sorry, this is really hard to see. Reactants. Therefore, increasing the product side and decreasing the reaction side. And following Le Chatelier's principle, you'll notice that it finds equilibrium and does whatever it can to take the stress away to get back to equilibrium state, no matter what. That is my explanation for the water equilibrium simulation experiment. I hope you enjoyed. Thanks for watching.